about this that tells me that maybe I should factor besides the fact that it's equal to 0. When I look at it, both terms, both this term and that term have a sign in them, sine of theta. Sine of theta is a factor in both of them, It looks like maybe sine of theta had been distributed in. I see that, I don't see that. And I think the other thing that I notice is that both of them actually have a negative as a factor in there too. And negatives are annoying for me, If there's so many negatives floating around. So I'm wondering, was there a negative that had been distributed in too? So what I'm going to do is I'm going to go ahead and factor this one. And I'm going to undistribute, factor out the common factor that's already there. This is the most basic type of factoring there is. You don't have to use the area model. You can just pull out the thing that they have, the factor that they have in common. They both have a negative in them, and they both have a sine of theta in them. So both terms. And what that's going to leave me with is, if you think about it, root of 3, right? Because now I can see if that orange got distributed into that term, it would make what I had. And I then also have plus sine of theta. 2 sine of theta. Just seeing if you were paying attention. That's all I was doing there. Or I made a mistake. No, it's not that one.
Could you also do it where it's negative square root of 3 minus 2 sine?
I did not have to undistribute or factor out a negative. I choose to just because I'd rather see the negative in one place than see it in 2 places. But it's not going to matter, right? As long as what we're doing is logical and makes sense, it's not going to matter how we solve it. And the reason that I factored is because think about it now. We have this blue thing times this orange thing, and it makes 0. Which means one of these things had to have been 0. What questions might you have at this point? Yeah.
This is kind of off a little bit, but on the first, the white equation, could you add? So this is kind of what I did at first. I just added both the square root of sine theta, and then I added 2 sine squared theta. So then you could just flip your sides and type it, so then you have positives on both of them. Or can I do that?
Can I add something to both sides of an equation?
Yeah.
Then absolutely you could.
Okay. I just didn't know how to mess up everything else, because then when you factor it, you have positive sign.
Wouldn't matter, right? Because if you look at it, here's the thing. What's going to make this thing here equal to 0? If sine of theta was 0, right? And if it had been this, was what you were arguing, what would have made that 0? If sine of theta would have been 0. It's not going to change anything. There's nothing crazy that we can't do in mathematics as long as it's mathematically valid, right? So what Caden's saying is what if I had taken both terms and moved them over to the other side, by adding to both sides? I see it as, if you don't like the negatives, couldn't I have multiplied both sides by a -1? I'd have flipped them both to positive 2, wouldn't it? And maybe that would have been a more convenient choice because I wouldn't have to see the negative. I was just explaining the way I saw it now. As long as what you're doing is mathematically valid, it's fine, right? There's lots of ways to solve something. So then come down here to the orange equation. I'm wondering, when is sine 0, right? Because that negative is not going to matter. Again, what we saw. This really just means that sine of theta would have to be 0. So at what values is sine of theta 0? At what angles makes sine 0? And we can see that would happen here. And it also happens here, right? At 0 and pi. And that's because we have no height, if you think about the opposite side of a triangle. So we know that theta could be 0 over pi, or pi, sorry. So there's 2 answers that came from our orange one. Those are solutions. Both work. And then we come over to the blue one. And again, this looks like the one we just did at the beginning of class today, right? I could just start to solve for this. So I'm going to subtract root of 3 from both sides. And I am going to say right here, there was somebody that had amazing work today on a homework quiz. Amazing work. You can see they knew so much. But because they didn't write down steps, they make little mistakes on positives and negatives. I'm not saying you have to write down this, you know. That didn't really highlight it, did I? But as long as you definitely need to show what you're getting to, you know. This is what they screwed up on right here. They all of a sudden had positive instead of a negative. And then I'm going to divide by 2, right? And I'm going to have sine of theta equals negative root of 3 over 2. So the question becomes, and this is what I think a lot of us missed, we were in the wrong quadrants. Which quadrants make sine negative? Down below. So we've got to be, and root of 3 over 2, I know the reference angle for that is 60 degrees or pi over 3. You know, so it's like this, but that's in the wrong quadrant. So I got to be like psych. It's got to be down here or here, because that would be the same looking triangle. It would just have a negative sine value. And so I know that that's 4 pi over 3 and 5 pi over 3. And so I know that those are now solutions as well. And for this one, it didn't say find all solutions. It said find all the solutions in the interval 0 to 2 pi. So it's literally asking me, go one time around, find the solutions that are in that one time around, and that's it. Right? And that's simple little interval. And I can't get any others inside of that. So I'm good. You know, otherwise I have to write the coterminal angles, you know, that whole plus 2 pi n thing. What questions do you guys have here?